Hello statistics students, Mr. Gazzato here. Yesterday we learned about the binomial distribution, and if you look at the screen there are four things to be binomial. There needs to be two outcomes, which we called success or failure. The observations need to be independent. The probability of success needs to be the same for each observation, and there needs to be a fixed number of trials or observations. You'll find this information on page 377 of the Bach textbook. Well, I'm going to summarize the question of interest. So in the cereal box they put basketball cards, and it says that 20% are LeBron James cards that I just highlighted in green. So the probability that you get a LeBron's card is 0.2. So I'm going to write P is equal to 0.2. And we want to know what is the probability that you get no LeBron sports cards if you buy 5 boxes. Okay, so we're going to say the probability of a success is that you get a LeBron card. And we know the probability of a success is 0.2, so the probability of a failure is 1 minus 0.2, or 0.8, since they are complements, meaning they need to add to 1. So if you bought 5 boxes, what's the probability that you do not get any LeBron sports cards? That means you have 5 failures. So I'm going to write the probability that x is equal to 0, meaning there are 0 successes or 5 failures. And the probability of getting a failure is 0.8. The next failure, 0.8. The next failure, 0.8. The next failure, 0.8. And the final failure, 0.8. And if you were to multiply those values out, 0.8 raised to the 5th, so you could write it as 0.8 raised to the 5th, you're going to get 0.32768. So now let's look at the next example. The next example says, what is the probability that you get 3 LeBron sports cards? So I'm going to write that as the probability that x is equal to 3, meaning there are 3 successes. So what that means is you get 3 successes and 2 failures. So I'm going to write this over here. You have 3 successes and 2 failures. Now what I just wrote down, I'm going to highlight this in pink, means I got a success, 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 fail, fail. But there's lots of ways that we could rearrange this. For instance, what I mean by that is I could have success, success, fail, fail, success. Or maybe I had the failures at the beginning and then 3 successes. So from a previous unit, we have 5 cards and we want to choose 3 successes. To find out all the different ways we can do this, we're going to do 5, choose 3. And when you do 5, choose 3 on your calculator, you get 10. And just to convince myself that there are 10 possibilities of arranging the 3 successes and the 2 failures, if you look at the bottom of the page, I wrote out all 10 possibilities. So it turns out that the probability that you get 3 successes means you're going to have 0.2 3 times. So you're going to have 0.2, a success, another success, another success, and then 2 failures. But you could rearrange this 10 times, so I need to put that 10 out in front. A shorter way of writing this would be 10.2 cubed times 0.8 squared. And when I type that into my calculator, I get 0.0512. Now there is a mathematical formula if the random variable is binomial, and I'm going to write down the formula. You don't need to memorize this formula. I want to show it to you in this example, and I'll show it to you in the next two examples. So the probability that you have k successes is, and we know that there are n trials, is n choose k, the probability of success to the k, and then 1 minus the probability of success to the n minus k. So if we look at the example we just did, I had the probability that x was equal to 3. So on my calculator, and there were 5 trials because you're choosing 5 boxes, I would do 5, choose 3, then 0.2 cubed, 1 minus 0.2, and then this exponent would be 5 minus 3, and this simplifies when you do 5 choose 3 on your calculator to 10, 0.2 cubed, and then 0.8 squared, which is the same exact way I did it earlier. So if we scroll back up to the first problem and we try to apply the formula, I'm going to rewrite the formula. Probably that x equals k is n choose k, p raised to the k, 1 minus p to the n minus k. So for this particular example, I want no successes. So that'll be 5 choose 0, 0.2 raised to the 0, and then 1 minus 0.2 raised to the 5 minus 0. And simplifying this, 5 choose 0 is 1, 0.2 raised to the 0 is 1, and then we have 0.8 raised to the 5th. And if you notice that, that is the same as what we did here in blue. So the point of me showing you the formula is to let you know that that does exist. And when you type this into your calculator, you'll give it 0.32768. And the graphing calculators also have a command, which I'm going to show you next. Okay, so let's come back to number 2. And in order to do this calculation, we could do it the first way that I'm highlighting in pink, but you have to figure out that there are 10 ways to rearrange the letters S, S, F, F. The second way is to use the mathematical formula here that I'm highlighting in blue and plug the values into that equation. And a more efficient way, or a calculator way, is to use what we call the Binomial Pdf command. And I'm going to show you how to do that on both calculators using example number 2. And I am perfectly fine if we use good notation and we use the Binomial Pdf command on our graphing calculator. So for this particular problem, the number of trials is 5. We want 3 successes. The calculators call that 3 successes, so x equals 3. And the probability of success is 0.2. So I'm going to do this first on the TI calculator, and you may want to take some notes on the commands. So on the commands, you're going to press second distribution, which is that red button, vars, and Binomial Pdf is letter A. So you can scroll up or down to letter A, or you can press alpha A. Some calculators are going to have this menu, so there were 5 trials, you're buying 5 boxes. The probability of success was 0.2, and you wanted 3 successes. And then you're going to press enter and paste. Some of you have the other TI graphing calculator, and what you're going to want to do is do Binomial Pdf. A parentheses will come up. You're going to type in 5, comma, 0.2, comma, 3, like you see on my screen, and you're then going to press enter. And when you do that, you get 0.0512. And if we go back to the worksheet, if I were to look at that answer, you can see it's 0.0512. Now let's do that on the Casio. On the Casio calculator, press Menu and number 2. And I'm going to hit Exit here. Your calculator probably looks like this. You're going to press Distribution, which is F5. Then Binomial will come up under F5. You're going to press Binomial. And you're going to use the BPD, Binomial PD function, just like the TI. So you're going to press F1. And it should come up with variable. If it doesn't come up with variable, you press F2. And we wanted 3 successes. There were 5 trials. And the probability of success was 0.2. You're going to move down to Execute and press Execute. And you'll see the same probability, 0.0512. So that's how you use the calculator commands for the Casio. Now let's take a look at this example here. And again, it does have to fit the binomial distribution or the 4 criteria. So in a store, out of all the people who came there, 30% bought a t-shirt or a shirt. If 7 people came in the store together, then find the probability of 3 of them buying a shirt. So there are a fixed number of trials. The trials, or N, is 7. We'll assume independence. The next criteria is success and failure. So success would be they buy a t-shirt or a shirt. And the last condition is the p-value, or the probability they buy a shirt, is always constant, which we'll assume is 0.3. So let's make an assumption of independence. 7 trials. The probability of success is 0.3. And there are 2 outcomes: buy a shirt or not buy a shirt. So for this particular problem, the probability that x equals 3, we could use this Binomial Pdf command, where n is 5, x is 3, and p is 0.30. If you wanted to use the formula, and I'm going to write the formula at the top here. In college, you may need to use the formula. So the probability that x equals k is n choose k, p raised to the k, 1 minus p to the n minus k. So for this example, it would be 7 choose 3. The chance of buying a shirt is 0.3, and you want 3 of them. Not buying a shirt would be 1 minus 0.3, or 0.7. And then this exponent would be 4, or 7 minus 3. And there's nothing wrong with typing this that I just highlighted in green, but I find it a lot easier to use the Binomial Pdf command. So let me do that on the Casio first. So to get that, you're going to press Distribution, Binomial, which is F5, Binomial PD, variable. So we wanted 3 people buying a t-shirt. There were 7 people, or 7 trials, and the probability of success was 0.3. And then you hit Execute a couple times, and you get 0.22689. Now let's do that on the TI. So you're going to go second distribution. I'm going to press alpha A, because I know it's the second distribution. It's letter A, so I'm going to go alpha A. And there were 7 trials. The probability of success was 0.3. And I wanted 3 successes. I'm going to move down to paste. Some of the other TIs, it'll show up Binomial Pdf. You put a 7, comma, 0.3, comma, 3. So the commands are number of trials, probability of success, and how many successes you want. And when I hit enter, you'll see you get the same answer as the Casio, 2269. So the answer here is 0.2269. We're going to take a look at another example here. So example 2. In a hospital, 60% of patients are dying from a disease. So the p-value is 0.6, and we'll assume that that stays constant. We'll assume the patients are independent, meaning one patient dying does not influence another patient dying. There are two outcomes, they either survive or die. And there are a fixed number of trials here. In particular, the number of trials are 8 that got the disease. So n is equal to 8. And I want to know what's the probability that 2 patients had died from this given disease. So you can see I wrote it in notation, probability that x equals 2. For those that are moving on to college, you may use the formula. So the probability that x equal k is n choose k, p raised to the k, 1 minus p to the n minus k. So in this example, 8 trials, we're going to choose 2. The probability of dying is 0.6, and we wanted to know the probability of 2 deaths. The probability of not dying is 1 minus 0.6, and if there were 2 deaths, that means there are 6 people that survived. Again, for our particular class, I'm perfectly fine if we use this Binomial Pdf command. This time I'll do it on the TI first. So I'm going to go second distribution. I'm going to go alpha A. You can scroll up or down to find Binomial Pdf. This time there were 8 trials. The probability of someone dying was 0.6, so the p is 0.6. And I wanted to know what's the probability that 2 people had passed away from this disease. I'll move down to paste. Some of you with the other TI, you want to type in what you see on the screen, Binomial Pdf, 8, 0.6, 2. And when you enter, you see the probability is 0.0413 approximately. Let me do that on the Casio. So for the Casio, I'll hit exit a couple times. So you're going to press distribution, binomial, F5 again, binomial PDF, or binomial BPD, so F1. And you're going to go down. You wanted to know that there were 2 deaths. There were 8 patients, so the trials was 8. And the probability of someone dying was 0.6. And when you hit execute a couple times, you see you get the same answer, 0.0413. So the probability that 2 patients died is around 4%, or 0.0413. For the next couple problems, we're just going to use the calculator commands, and you could see this on page 383 of your textbook. So a research company is making phone calls, and they believe that they make contact with 76% of the households. So the p-value is 0.76. We'll assume that the trials are independent. The number of trials is right here. They're going to make 12, so there are 12 trials. And the probability of success, we'll assume, is 0.76, remains the same. Okay, and we're only going to do part A of this problem today. So I want to know the probability that 9 calls are successful. So this time I'm just going to use my calculator command. Number of trials is 12. The p-value is 0.76. And we want 9 successes. So this time I'll do it on the TI first. So I'm going to go second distribution. I'm going to scroll up or down to letter A, or you can press alpha A. So we had 12 trials. The probability of success was 0.76. And we wanted to know 9 successes. And I'll move down the paste and press enter. Again, some of you have the other calculator, so you want your screen to look like this. Binomial Pdf 12, 0.76, 9. When you would enter, the probability that they make 9 successful phone calls is 0.2573. Let's do that on the Casio. So on the Casio, you could hit execute again if you were there, and I'm just gonna move up. X was 9. I wanted 9 successes. N was 12. We did 12 trials, and the probability of success was 0.76. And hit execute a couple times. You can see on the screen that the Casio and the TI gave you the same answer. So the probability that there were 9 successful calls is 0.2573. The next class we'll talk about parts B and